Alright, welcome to part 2 of the Fuzz face pedal that I got currently on my bench here that I'm building. As you can see, I got the metal box all drilled out for the holes. Power connector on the back. We're going to use the basic switching power supply adapter because, you know, keep it easy. Has a standard barrel jack. Now this power supply right here is a 12 volt power supply instead of the regular 9 volts that most people are used to seeing. But there's a reason I did this. As you can see, I can do this here. So it's going to fit pretty standard jack, same exact kind of jacks you use on majority of guitar pedals, like Bose pedals and such. So anyway, I'll get to that here in a second as to why I'm doing 12 volts instead of 9 volts, but this circuit will run on 9 volts after my modification. So right here we got the circuit, which is very, very simple. I mean, this is a 2 transistor fuzz phase, so it's like the original Jimi Hendrix version. You can see that's going to fit right about there, and all these loose wires will connect to the potentiometers, audio jacks, power jack, and LED. Should be for the power indicator. I'm thinking about going with yellow because I like yellow. So you're probably noticing right off the bat here the wires out of the way here. Connector strip right here. I didn't want to solder directly to these germanium transistors because they are old and they don't like heat. Not like modern day transistors. These things can be fried if you put enough heat across them. Even the modern ones. This is a more modern one I got. This new old stock germanium, which was let's see here. I think I had it written down. I'll see if I can see what it says here. It's a 3AX31B, and I only have one of these working because I got a pair of them and one of them was dud. So with the socket we could just pop the transistors in and we can use any pair of transistors we want. I have this written here, if you can see, emitter, base collector, and then emitter, base collector for the first transistor, second transistor, and I added bias controls. I guess you'd call that bias. It's from the collectors of the transistors. Instead of going with the original 33K resistor there, we went with a 22. Over here, instead of the original 8.2K, we went with a 2.2K. And then we are installing a potentiometer, internal one, these little black adjustments right here. Single turn potentiometer. We got a 2.2 plus 10K there. So we can get in the 8.2K range, but this allows us to really dial it in. Then over here, same thing. Instead of 33K, we got a 22K resistor we replace that with. And I got a 30K variable resistor, which is this one right here. 333 is the part code. Another thing I did, modification, is I added an RFC, what's called a radio frequency choke, because we live right next to a radio station and it likes to get into our guitar amplifiers, audio amplifiers, stuff like that. So that'll block RF from getting in, which is something that a lot of guitar pedals should have if you're around high power radio stations. So solder's all nice and cleaned up here. So one of the major modifications I did, and I don't know if this will show on camera very well, but we have a Zener diode right there. Now over here, we lifted the ground, so by lifting the ground, we put the ground on the jacks, which is actual legit ground. and our negative 9 volts, of course, because these are PNP transistors, not NPN. So by lifting the ground, what we've essentially done is allowed us to have a actual ground on the box, guitar pedal box. So we lifted the ground and we're putting positive as its own line right here up to a Zener diode, which is a 9 volt Zener diode that regulates the voltage no matter what we give this thing within, reason. The Zener diode will regulate it down to 9 volts through a 330 ohm resistor, which picks up the slack in case we're running higher voltage. And that goes up to our power jack, which is 9 to 15 volts DC. I figure is a good range. So 12 volts, like I said, the 12 volt power supply I was talking about right here falls within that range. And we can use the original 9 volts DC too if we want. But what this allows us to do by lifting the ground is we can have a center positive and an outer negative. I can reverse that if I want to. But it keeps the audio jacks at actual ground. So if these pedals are daisy chained to something that has a negative ground, it's not going to feed positive ground, if that makes any sense, and it won't fry the pedals, plugged into it, ahead of it, or behind it, if they're all using the same power source. So that's where I'm at anyways so far. The transistors will install there. Of course, this is going to fit down here. I gotta put some kind of protective thing here so this, of course, doesn't short out. I found out these germanium transistors, the outside canister is not connected to the collector or the emitter. So if these were to touch the body of the case, not an issue. I guess that's just mainly for shielding. Not sure exactly how that is. Germanium transistors haven't been used in electronics for a long time, which is why they were kind of sought after for these kind of guitar pedals. Kind of like old tube enthusiasts liking their vacuum tubes. But so that's where I'm at so far. I'll probably add some pictures of the build process from here. Not sure exactly how I'm going to plan out this video from this point on. But gives an idea of some of the modifications. I'll add an LED light too, which is on the switching circuit. We're using true bypass for the push switch. So we'll see where we go from here, and I'm gonna have to plan out this video a little bit better because this is kind of on a whim here. So I just wanted to make a quick correction real quick because I kind of forgot I did this. So first of all, we no longer have the ground reference there, and I want to make sure people understand what we're doing here. But the Zener diode, we're pushing out positive, and we're referencing ground on the actual ground. So we are taking and lifting the ground from here, which is normally negative 9 volts, because PNP transistors are kind of the opposite of NPNs. You get negative feed them, and then ground reference is actually positive if you want to look at it that way. So this line right here from the Zener diode, from the input, positive 9 volts, is going through 330 ohm resistor, which is taking up the slack. And as I said, that's actually doing is it's reducing current across the Zener diode. So the Zener diode, this is a very low current circuit in the first place. And this thing could run on a 9 volt battery for, months, maybe years. So anyways, we're pulling it from positive 9 volts to our so-called ground, which is lifted. And it's only going to 2 points. It's going to our first transistor's emitter, and then of course up into the fuzz control. Now this resistor right here, I forgot to kind of erase that. That was actually because I was originally wanted to use a 5K potentiometer there. Now I realize it doesn't work so good when you plop a 1K ohm resistor across there to make a linear tap clockwise control work, because the fuzz is only in like the last 10-20% of the control. We don't want that, so I forget that. We're actually going to use a 1K clockwise control instead of a 1K counterclockwise, because that's all I have at the moment. So the other thing was, I want to mention the input capacitor, because we're lifting ground here, and this is actually going to reference ground now instead of referencing the positive 9 volts or something like that. So we want to flip over the capacitor. Normally the original circuit had positive on the input of the audio jack and negative. Now it's possible to use a non-polarized capacitor, of course, but to do that it would require a bigger capacitor, or you can put 2 capacitors in series back to back, you know, negative, negative, positive on one side, positive on the other, kind of like let's see here, something like that. So, you know, you have negative here, positive there, and then there would be your connections. That would also be a non-polarized capacitor. I prefer not to do that. So I noticed the voltage on the base of the transistor is actually more in the positive range, so we're just going to put the positive over there. Now there's a website for this that describes how to do this. It's called www.music.com/lab/fuzzface.htm, which I recommend you guys visit if you're curious about how to get a negative ground instead of a positive ground reference. And the reason for this is because if you have a positive ground reference on the aluminum body, or if you daisy chain this with other pedals sharing the same power supply input, what you're going to do is you're going to create a short circuit, and it's going to hopefully not fry the actual board that you have your pedals plugged into, but it could, well, it'll cause a short, and so your pedals aren't going to work if they're all powered by the same power supply. So doing it this way, having a negative ground reference actually tied to the aluminum box, and that includes the audio jacks, because remember, most of these boxes, the audio jacks, the outside is grounded to the actual box, will allow for it not to short out. So I wanted to insert this video real quick to make sure people get that. The other thing is, I made a mistake. It's not Bose, it's Boss. B-O-S-S. This is one of my old HM2 guitar pedals. So, I don't know, maybe it is Boss. I probably pissed off some people saying Bose. So, anyway. Hey, look at that. Look at that. It's a guitar pedal. But there's another change I had to make. Alright, on the schematic here, turn up the light. I had a 470 UF capacitor across a Zener diode, and this thing was motorboating when I turned the guitar input all the way down to 0, which is basically shorting out the input right here. So I was wondering what was going on there, and then I realized, looking at the schematic where the ground path follows, it's going through the 470 UF capacitor. So I popped in a 220 2200 UF capacitor, which is this big guy right here on the corner, and I got rid of that issue. So just a little quick update. I'm not sure why that was happening, if it's because of the gain of the transistors. I just want to make that little update real quick. And the other thing is, I think I'm gonna put a protection diode on the input too, so reverse polarity is not gonna fry anything in the chain ahead of it. But so yeah, anybody that's gonna build this circuit and wants to remove the ground path and put it on positive so that your ground path is on negative, however you want to say it, so that the shell is on the negative of the power supply, you're going to need a big fat capacitor. Otherwise you're going to probably get feedback and it's going to create oscillation. So not sure why that happened, but now we know. So from 470 UF to 2200 UF, and it seemed to cure it. Just for future reference.